Hello over there. Good morning, good afternoon, good evening, my dear students. This is your one and only AG sir, and today we are here with NLM series, exercise 2, level 1, not 2, level 1. In that, we are going to discuss string constraint and wedge constraint. Okay, the first question is the pulleys in the diagram. The pulleys in the diagram are all smooth and light, and the acceleration of A is upward and that of C is F, and that is downward. The acceleration of B is acceleration of A is upward and that is A. Acceleration of C is downward and that is F. And what will be the acceleration of B? See, here we have too many options, but majority of options are upward. So I am considering that the acceleration of B is upward and value of that acceleration is B. You can consider downward also, not a big deal. Okay, so I have considered that the acceleration of B is in upward direction. Okay, now applying the point method, this is point number 1, point number 2, point number 3, point number 4, point number 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Like that. So applying the point method, can I write acceleration of point 1 as minus A? Why minus A? Because point A is reducing the length. Minus A for point B 0, for point C 3 0, for point 4 is reducing the length, so I will write minus B, plus 0.5 is reducing the length, so that is minus B, plus 0.6 0, plus 0.7 0, plus 0.8 is increasing the length, so plus F equals to 0. So here we have equation that minus A plus F equals to 2B. So acceleration we got is 1 by 2 into bracket F minus A, which is in upward direction. So do we have such option? Yes, we have option A, 1 by 2 F minus A upward. Okay, the next question is acceleration of A is 2 meter per second square leftwards, 2 meter 2 2 2 2 2 2 2 2 2 meter per second square. Acceleration of B is 1 meter per second square leftwards, in this direction 1 meter per second square, and acceleration of C is upward, downward, downward, upward. I don't know, but I am considering that the acceleration of C is upward. Okay, and that is a small c. Again pointing out all the points. Point number 1, 2, 3, 3, hello, what are you doing? 3, 4, 5, 6, 7, 8, 9, and point number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, applying the point method. Point number 1 is decreasing the length, so for that minus C. Point 2, that is 0. Point 3, that is 0. Point 4 is increasing the length, so for that plus 2. Point 5 is increasing the length, so for that plus 2. Point 6 decreasing the length, so for that minus 1. Point 7 decreasing the length, minus 1. Point number 8 doing nothing, 0. Point number 9 doing nothing, 0. And point number 10 decreasing the length, so that is minus C, which means 2C equals to 4 minus 2, that is 2. So C is 1 meter per second square. So we got the answer positive. Answer is positive, which means the direction we have considered is correct. So C is going upward with 1 meter per second square. Do we have such option? Yes, option A. Acceleration is 1 meter per second square, and that is upward. The next question is block A has velocity 0.6 meter per second towards right. Block A is going in this direction, 0.6 meter per second, 0.6 meter per second. Find the velocity of block B. Okay, so pointing out all the points. First one is this 2, hey 2, 3, 4, 5, 6, 7 and 8, and I am considering that B is going in downward direction. Okay, so whatever the acceleration of A will be, that will be the acceleration of this bigger pulley, so that will be the acceleration of this point, so that will be the not acceleration but velocity, so that will be the velocity of this point. So this is point number 1, point number 1, 2, 3, 4, point number 5. Hey, don't do this, man. Point number 6, 7, 8. Okay, so point number 1, applying the point method. Point number 1, decreasing the length, so that will be minus VA. Point number 2 is fixed, so that is 0. Point number 3 fixed, 0. Point number 4 minus VA. Point number 5 minus VA. Point number 6 0. Point number 7 0. Point number 8 plus VB. So we get VB equals to 3VA is equals to 3 times 0.6. So we have answer 1.8 meter per second, and our answer is positive, which means the direction we have considered is correct, and the direction we considered is downward. So answer is 1.8 meter per second in downward direction. Option is correct. Next question is block B moves towards right with constant velocity V0. Velocity of A with respect to B, relative to B. Applying the point method first of all. Point number 1, point number 2, point number 3, point number 4, 5 and 6. Okay, naming all the points. 1 2 3 4, 1, 2, 3, 4, 5 and 6. Applying the point method, point 1 is going nowhere, so 0. Point 2 is going towards right with velocity of b, so that is increasing the length, so for point 2 we will write plus v naught. For point 3 again plus v naught because increasing the length. Point number 5, I am considering that a is going towards right, so point number 4 is decreasing the length, so that is minus va. Point number 5 minus va. Point number 6 plus v naught. Summation of all of this is 0, so we have answer 2 va is equals to 3 v naught. So va is equals to 3 v naught by 2. Okay, and we have options that 3 v naught by 2 towards right. Is this our correct answer? I don't know. Velocity of this is v naught, velocity of this is 3 v naught by 2, and direction is this, and the asked question is velocity of a relative to b. So they have asked for velocity of a relative to b, velocity of a relative to b is equals to va minus vb. So va is 3 v naught towards right, 3 v naught by 2, velocity of b is v naught, and our answer is v naught by 2. Answer is positive, means that is right, towards right. So correct answer is option D or B. Correct answer is B, not D. Okay. Next question is point method. Acceleration of c with respect to ground, and here we have given that acceleration of a is in this direction a and b is in this direction b. Pointing out all the points. Point number 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so first of all applying the point method. So point number 1, this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8. So for point 1 acceleration is reducing the length, so minus a. 4.2 minus b. 4.3 0, 4.4 0, 4.5 minus b, 4.6 minus a, and acceleration of c is in the downward direction, so plus ac, because that is increasing the length, equals to 0. So here we have ac is equals to 2a plus 2b in downward direction. Okay, so ac will be minus, not a minus but plus a I cap minus 2a plus 2b j cap. Why? Because this block C is attached to, remains attached to block A. Block C remains attached to block A. This is the acceleration of C which we got in downward direction, but keep in mind that C is going downward as well as it is going towards right. So this is A and this is 2a plus 2b. So acceleration of C becomes a I cap minus 2a plus 2b j cap. So our answer is option A. Acceleration of this wedge A. Okay. So here we have two components. horizontal and this surface is making angle alpha, so this is the again angle alpha 1. So this is a cos alpha 1 and this is a cos alpha 2. And as we can see that this wedge is going in this direction with acceleration a cos alpha 1, I must say that this ball is also going in this direction with acceleration a cos alpha 1. That is must as a wedge constraint. Okay, and I can see that this ball is moving in this direction. The ball is moving in this direction or upward direction. You can consider any one. Let us consider that the acceleration of ball, let me consider dark pen, acceleration of B is in this direction, not vertical but parallel to the, sorry for these two arrows, but parallel to surface, and that is B. Let us consider that. Then the angle between these two is alpha 2. So can I say let me first of all take two components. This is hey, what are you doing, man? This is B cos alpha 2 and this is B sin alpha 2. So can I write that A cos alpha 1, which I got from here, from this wedge, is equals to B cos alpha 2 from this ball. So can I say that B is acceleration of B is equals to A cos alpha 1 by cos alpha 2. Do we have any option like this? A cos alpha 1 by cos alpha 2? Yes, we have option A. Option A is our answer. Okay. So next question is, in the arrangement the pulleys and strings are ideal, the acceleration of block B is okay. First of all, mg tension, and here we will have T by 2, T by 2, T by 2, T by 2, T and 2T. Okay, and acceleration of this one is in downward direction. Let us consider downward direction A, which means if we apply the string constraint plus A plus 0 plus 0 consider in upward direction, so plus a pulley. Let me draw this. Point number 1, 2, 3 and 4, applying the point method, and I am considering that the acceleration of this point is in downward direction, which means the acceleration of this pulley must be upward direction, and that must be A, because this rope, length of this rope must not change. Okay, so this is for the first one, that this pulley is going upward with acceleration A, that is I have considered. Then point number, again applying the point method, 1 2 3 4 5 and 6. For these 6 points, first we took another string, this one string, now we are taking this string. Can you notice? Okay, this string which is having 1 2 3 4 5 6 points, 6 points of contact. Point number 1 2 3 4 5 and 6. Okay, applying the point method, we will get point number 1, acceleration of point number 1 is 0, for point number 2 that is 0, for point number 3 that is 0, point number 4 is going upward with acceleration a, so that is increasing the length, means plus a. Point number 5 increasing the length, so that is plus a, and point number 6 I am considering that it is in upward direction, so that is minus ab equals to 0, so I got ab equals to 2a. Now let me draw the FBD. Block M, this is for point A. Tension is in upward direction, mg is in downward direction, and acceleration is a. And for point B, mass M, for point B, mg is in downward direction, t by 2, tension is half, t by 2 is in upward direction, and acceleration I have considered is in upward direction, and that is 2a. Now writing two equations. For this, F net equals to ma, and for this, F net equals to ma. So what will happen? We will write mg minus t equals to ma. For point A, we will write mg minus t equals to ma for point number 1a. And for point B, we will write T2 minus mg equals to ma. T by 2 minus mg equals to m into 2a for point number B. For point number B, and this is for point number A. Here we have written F net equals to ma, and here again we have written F net equals to ma. Okay, so for equation 1 and equation 2, writing equation 1 mg minus t equals to ma, and writing equation number 2 by multiplying 2, we will have t minus 2 mg equals to 4 ma. Adding both the equations, t and t is gone, so minus mg equals to 5 ma. So m and m are gone, and acceleration is minus g by 5, which means the direction we have considered is opposite to actual direction. So actual acceleration is not red. This is the acceleration of this point is g by 5 in upward direction, and for this point it will be 2g by 5, twice 2g by 5 downward direction, and they have asked for acceleration of B, that is 2g by 5 in downward direction. Okay, this much is enough for today. The end. Thanks for watching. See you in the next class.